Hey, let's look at number 27 on page 194. We're looking for the extreme values of the function y equals the square root of 3 plus 2x minus x squared. And we are not given a range of x values, an interval that we should be looking for. So we really want to look for the extreme values over all real numbers, all values where this function exists. And it's important to think about, where does this function exist? We're taking a square root here. If this business underneath the square root sign is less than 0, then the function doesn't even exist. So we need to be thinking about where that is. We're going to see it when we look at the derivative here. So we're going to go ahead and move on to the derivative. The derivative of this thing is 1/2 times the quantity 3 plus 2x minus x squared to the negative 1/2 power times the derivative of the stuff inside the square root, which will be 2 minus 2x. Okay? We can simplify this a little bit. This part here with the parentheses and the negative 1/2, I'm going to get rid of the negative exponent by putting it on the bottom of a fraction. And the 1/2 means it's a square root. So we've got the square root of this. 3 plus 2x minus x squared, all underneath the square root. That's on the bottom of the fraction. On the top, we still have the 1/2 and this quantity. If you distribute the 1/2 through these parentheses, 1/2 times 2 is 1, minus 1/2 times 2x is x. There's the derivative. That's y prime. We're looking for critical points, which we get when the derivative, don't know why this thing isn't responding better, is equal to 0, or when it doesn't exist. That's a D. Okay, so when does the derivative equal 0? When does it not exist? The derivative's a fraction. The only way a fraction can equal 0 is if the top equals 0. So that's going to give us x equals 1. The only way a fraction could not exist, well, the most common way for a fraction to not exist is if we divide by 0, if we have 0 on the bottom. So we've got a square root of this thing. If that's going to equal 0, then we don't even need the square root. The stuff underneath the square root has to equal 0, because square root of 0 is 0. So what we're really trying to decide is, when does 3 plus 2x minus x squared equal 0? It's a quadratic equation. You can use the quadratic formula on it if you want. That's not a bad idea to make sure that you've got that memorized. Or we can factor it. 3 minus x times 1 plus x will give us this if you FOIL it back out. 3 times 1 is 3. You get a negative x on the inside and a positive 3x on the outside, so that's positive 2x. And then you have negative x times x, that's negative x squared. So that means our answers are when 3 minus x equals 0, that's going to be x equals 3, or when 1 plus x equals 0, which is negative 1. So those are our candidates. X equals 1, x equals negative 1. Let's change this one to a negative 1, then we'll put 1, and then we'll put 3. That way we've got them in order from least to greatest. Now let's think about what y is in each of these cases. If we put negative 1 into the original equation, we have 3 plus a negative 2, that's 1, minus negative 1. Ugh. Now my answering machine's going. You get to listen to that. And it's a wrong number. How awesome is that? Okay. It's... You gotta be kidding me. It's 3 plus a negative 2x, so that's 3 minus 2 minus 1 is 0. We put in 1, we get 3 plus 2 is 5, minus 1 is 4. We put in x equals 3, we get 3 plus 6, that's 9, minus 3 squared is 9, we're back down to 0 again. So, what are our extreme values? Well, these are the only candidates for maxes and mins, and this one is the highest, so it must be a max. These two are the lowest, so they must be mins. And we're done with the problem. Now, I'm going to keep going. If you're only interested in the calculus of this, go ahead and stop. But you really ought to be thinking, hey, what does this graph look like? Why are these mins and maxes? What is this thing doing? Okay, so we're going to take a look at that because it's a good review of some stuff we already know. I'm going to rewrite the equation here. Y equals the square root of 3 plus 2x minus x squared. All right, well, we're going to take the square root, and we're going to remember that if we take a square root, we have to say, well, there's a positive 1 and a negative 1. But if the equation has a square root in it, then it's assumed to be the positive square root. So right away, looking at this equation, we know that y equals the positive square root of this. Well, that's only going to happen for positive y. There's no way that we're going to get a negative number out of this because the square root is assumed to be the positive square root. So, right off the bat, we should say, oh, that equation, y is greater than 0. Or equal to 0. But not negative. All right. Now, what's this graph look like? Here's a way we can find out. I'm going to square both sides to get rid of my square root. And I'm going to write the terms in the opposite order here, just to put the x squared first, the way we're more used to seeing it. Now, I'm going to do something that you'll remember from math analysis. Factoring a minus sign out of the first two terms here. Whoops, so that should be a minus now. Now I factored this minus sign out. If this had been negative 2x squared, I would have factored a negative 2 out. If it had been positive 5x squared, I would have factored a positive 5 out. I'm factoring out the coefficient of the x squared term. You'll remember that that's the first step in the completing the square method that we did in math analysis. I'm factoring out the coefficient of x squared, and now I'm going to complete the square inside these parentheses. In order to do that, you take half the coefficient of the x term, so that's going to be negative 1, and you square it. Negative 1 squared is positive 1, and we add that in. But I can't just add something in, I have to balance it out, otherwise I've changed the equation. So let's think about what I've actually added in. I added a plus 1 in, but it's inside these parentheses and there's this minus sign out front. So when we distribute that through, that negative goes on to this plus 1. I really added a negative 1. So in order to balance it, I need to add a positive 1 so that I haven't actually done anything. So out here, outside the parentheses, I'm going to add a plus 1. Take a second to make sure you understand that that plus 1 and this plus 1 actually cancel each other out, so we haven't really done anything. We've added 1 and taken 1 away. We've added 0. The nice thing about doing that is now this set of parentheses here is a perfect square. It's x minus 1 quantity squared. Take a second to see why that's true, and then move on. Now that we know that, I'm going to add the x minus 1 squared over to the other side. And look at that. That right there should look a little familiar to us. It's the equation of a circle. X minus h squared plus y minus k squared equals r squared. That's the equation of a circle with its center at hk and a radius of r. That means this right here is a circle with center at 1, 0, and radius 2. Remember that 4 is r squared. Well, so what's that look like? 1, 0. Radius 2 is going to go back over here to negative 1 and all the way over here to 3. And it's going to look something like that. But we're only keeping the top half of the circle. Why? Because we said we only had this positive part of the square root. So where do we have the mins? We have the min over here, and the mins over here. Where do we have the max? We have the max up there. That's the min and the max that we found in the beginning of this problem. Min at -1, min at +3, max at x equals 1.